next we will start the polynomials in Scilab programming. Just 1 minute, please. प्रदीप वो हो गया था सिस्टम का? अच्छा, करके मुझे बताना, ठीक है? ओके. Okay, next we will start polynomial. So to create any polynomial, we have to give the command poly, P-O-L-Y, right? And we can write the coefficients or the roots here in A. A is a matrix which can contain the coefficient or the roots of a polynomial, and as well as the variable name, and then is your flag. Flag means the values which are present in A, these are roots or these are coefficients. Just let me describe what is this. For example, what is polynomial? For example, if we write that 3x square plus 4x plus 2 is equal to 0. So this is a polynomial of degree 2, right? Variable as your x. Now what are the coefficient? Coefficient is your 3, 4 and 2, right? So if we want to create this type of polynomial, we can write P is equal to poly, right? This is your small letter poly, not P is small letter, poly. Within bracket, we can write the coefficient, that is your 3, 4 and 2. This is the coefficient. Then comma, then is your variable name is your x, that is within quote, and then comma, that is your flag. Flag means whether it is a coefficient or it is a root. You can write the C. C means it is a coefficient. Then of course you will get this polynomial, that is your 3x square plus 4x plus 2. Now let us see that whether it is same or not. Now we will go to the Scilab. Right? We are writing P is equal to poly. Then within bracket we are writing 3, 4 or something I have given 2, comma, then within quote x, because this is my variable, comma, then within quote C, because, sorry, within quote C, that means this is these values, that is your 3, 4, 2 are my coefficients. So you can get 3 plus 4x plus 2x square. That means first one it is taking as your constant, next one is your x part, third one is your 2 part, matlab the coefficient higher part. So what we can do, we can just do the opposite, that is your 2, and then we can just write 3. Then you will get 3x square plus 4x plus 2. This is actually Scilab takes first one as your x to the power 0, second one is your x to the power 1, third one is your x to the power 2, fourth one is your x to the power 3, and so on. Now, for example, if you do not write anything, for example, if you are writing that 0, 3, and then you can write another one, that is your 4. Now if you say you will get 4x cube 3x square plus 0x, matlab that is value 0 and plus 2. That means if you want to omit any value, then you can just write 0 into that, right? So this way you can just define a polynomial, right? If you don't write poly command, then what will happen? For example, if you write directly, that is P is equal to you can just say why we can't write 2 into x square then 4 into x plus 3. You cannot write like this. For example, I cannot write like this, that 3 say multiply y then square then plus say 4 2y plus say 5. I cannot write this, it will give the error. Which error? It will give the, oh sorry, y is already there, that's why it has taken. Let me take the another variable, say for example z. New variable, let me take. Oh, z is also there. Okay, some other variable, let me take. Say m. Right. So why it was giving for y and z? Because in our variable that you can just say some y and z values I have somewhere I have taken. So that's why it is giving the original y and z value it is taking. But if you are writing p is equal to 3 into m square plus 4m plus 5, m is a variable, then it is giving undefined variable. You cannot just write this one. So if you want to write like this, that is in polynomial expression, then you have to give this poly command, that is a poly a variable name flag. Now, what is the purpose of roots? Roots purpose is that whenever you know that with those roots, you have to find the equations. For example, let me just say the same thing I am giving, for example, r, that is 2 and 3 and 4 are the roots of the polynomial equation. Now let us see that what it is gives. It is giving x cube plus x square minus x cube minus 9x square plus 26x minus 24. That means 3 roots, that means x cube are there, then it has the 3 roots are there, 2, 3 and 4. Now if you just see that how these equations will be formed if there are roots, then what will be the equations? I have given that 2, 3 and 4, right? My roots are 2, 3 and 4. Now what will be the equation? X minus 2 into x minus 3 into x minus 4 is equal to 0. When you multiply it, what you will get? X square minus 5x plus 6 multiplied x minus 4. Let me take the another color so that it will be clearer to you. In color, let me take as your white. So x square minus 5x plus 6 into x minus 4, that is equal to, if you multiply x cube minus 4x square minus 5x square, that is minus 9x square minus 20x plus 6x. There is some okay, minus plus 20x plus 6x, that means you have plus 26x and then minus 24. So you can just write that x cube minus 9x square plus 26x minus 24. You just see this is the equation we have got here. In Scilab also we have got the similar expression, right? So this is the expression we have got, right? So this is the difference between the R and C. If you are taking C, then the expression we will get 2 plus 3x plus 4x square. But same thing if you are giving as a root, then we are getting such type of expression. And you see that to calculate this expression is very much tedious work if you have more than 4, 5 roots. For example, you can just give the many roots if you are want to give, and accordingly the expression will come before you. Or you can give the the solution. To find the solution, if you can give the coefficients and this, then also you can find out the solution. Now I will just tell you, this is that if you know the roots and if you know the coefficients, how the polynomial. Now I will tell, if you have the polynomial, how to find out the roots, right? That is also another important thing. For example, I will just tell, yes, for the roots find out, we can say roots P1. So any polynomial, if you have, so then finally we can just write roots of that polynomial, and P1 we have to if we have, then automatically the roots can be find out. Now let us see that how to find out the roots. Okay, let me just check out. So this is my P. I have find out P is equal to this thing, right? Now we will do ulta. That is, you have the polynomial and you have to find out the roots. Now I am saying that roots of P. If I say roots of P, you just see 2, 3, 4, 5, 6, 7. These are my roots, and you just see 2, 3, 4, 5, 6, 7. These were my roots. So from the roots, you can find out the polynomial. If you have the polynomial, then you can find out the roots, right? And to write the polynomial, what you can do, for example, I am writing, I want to find out roots of a very typical solution. For example, in to the power 5, right? I have some expression in terms of x to the power 5, and I want to find out the roots. So what I will do, first of all, I will just define the polynomial. For example, I can just take P1 equal to poly of, right? Poly of, and what are the coefficients? I know, I have the equation, so I know the coefficients. For example, I have the coefficients, say 24, then say 48, then 23, then these are my coefficients. For example, minus 45, then you can say 12. That means your 24, our polynomial is 24 plus 48x plus 23x square minus 45x, 24 plus 48x plus 23x square minus 45x cube plus 12x to the power 4. So this is my coefficients, right? So I can find out x, right? And I can find out that these are my coefficient C, right? So this is the polynomial I have written. Now I have to find out the roots of this polynomial. So I will just write roots of P1. So whatever the value will be there, this is my imaginary number. So this plus something I, this plus something I, this plus something I, this minus something I. So this is my 4 roots, because it is to the power 4. So these are the roots I have found out. So it is very much helpful if you do some equation in mechanical field or electronics field also. Somewhere you have many equations of to the power with a higher power order of equations. From there you directly you want to find out the solutions. So this is the right way to find out the solutions, right? Okay. So what I told about the poly, and after that, this is one important thing. You can do this part, because for example, if you write poly 0x, then what will be the what is the equation? What will be the equation? By default, this takes as a root only. By default, if you do not write, then these value are the roots, right? So if I find that poly 0 comma x, that means 0 is your root. That means the equation will be x minus 0, right? X minus 0 equal to 0. That should be our equation. For example, 1 and x, इसका मतलब क्या है? X minus 1, that is your, actually 1 is your root, so polynomial is x minus 1. Similarly, poly 2 comma x, that means the polynomial is x minus 2, right? Then is your 2x coefficient, that means coefficient. Coefficient means that is equal to only 2 you will get, because this 2 is a coefficient, that is x to the power 0. So the value you will get only 2. Now let us see that whether we are getting the exact things or not. First of all, let me just tell that poly 0x. Now let us try this. What will be poly 0x? You see, only answer equal to x, because we have already seen that we should get x minus 0, that is only x, right? Next is your we are giving that poly 1x. Now we are getting x minus 1. You see, I have told you that we should get the x minus 1. So we are getting x minus 1. Similarly, 2x, when we'll give that, we will be getting x minus 2. Next one, what we have seen, that is your your coefficient. So we should get only 2, right? So let me just paste it. You just see only 2. Why it is 2? Because only one term is there, and this is a coefficient of x to the power 0. That means only it will give me the value of 2, right? So another one, that this already we have done, that what it will be there if we give the C, that is your 2 and 3, that is your coefficient. So first one only 2 and next one is your 3x. That I have already told you, right? And if you set this is 0, roots, then we will give that these value are the roots, that means x minus 2 into x minus 3. So that is your x square minus 5x plus 6. So this is your polynomial, right? Next, we have created some polynomial multiplication you can do, polynomial divisions you can do, polynomial plus you can do, polynomial multiplication p1 into p2. But polynomial, you have to make the polynomial, then you can do the addition, subtraction, multiplication and division. Roots and coefficient. To find out the roots, we use the roots. To find out the coefficient, we use the COEFF. For example, we have done something, no, here we have done here, that is our P1, right? Now if I say that COEFF, coefficient of P1, so we should get this value 24, 48, 23, minus 45 and 12. You see, these are my coefficient 24, 48, 23, minus 45, 12. So for the find out to find out the coefficient, we use the COEFF, and to find out the roots, we give roots. Next is your derivative. What is derivative? For example, we have the equation, we have found out the equation that let me write that. For example, we have written 3x square plus 2x minus 4 equal to 0, right? So what will be the not equal to 0? This is equal to, for example, this is my fx, right? Now what it will be the dfx by dx, ddx of fx will be, that will be 6x plus 2, right? We calculate 6x plus 2. Now, if it is a long equation, if it is a very, the coefficient is very much high and all these things, so to multiply, to divide, all these things, it will be a large amount of work. So for that, we use the derivative of p. Whatever fx is there, whatever p is there, if we just write derivative of p, then automatically what is p, that you have to declare, and after that it can be calculated. Now let us see that whatever we have found out, that is your, our poly 1 is your much higher value, sorry, p1 is a much higher value. So if I write that derivative of p1, this is on variable. So we can just see that it is giving 48 to the power x cube, 45 into 3, that is 135 into x square, then 23 into 2, that is a 46x, plus this is your 48. So this is your derivative of this equation. So similarly, we can get the derivative of p1 into p2, whatever value you want to give, right? This is your derivative. Next is your Horner. Horner is your that to find out the value of the polynomial at that value, right? Find out the polynomial value of the polynomial at that value. That means if I say Horner right? Horner P1 comma say 2, right? So it is giving 44. That means what? 24 plus 48 into 2 plus 23 into 2 square minus 45 into 2 cube plus 12 into 2 to the power 4. So whatever value will be there, that is actually, it is your 44. If I say Horner 0, then it should give only 24. So it is giving 24. So Horner is a function that is used to find out the value of the polynomial at that particular value. This is your Horner, right? Next is your factors. Factors is your whatever polynomial is there, how to find out the factors. If I say that factors of P1, then whatever possible way it will do the possibility. It is not that this x square also, it is not possible for the system or this to factorize anymore. That's why it has stopped, right? If I say, for example, for example, okay, this is the equation, right? If I say factors of, say, I have not given ANS, for example, it is only ANS is your this only. So the factors of ANS, because it is an answer, it is coming, so it is coming to the ANS variable. So if I give the factors of ANS, okay, it is not taking. Okay, let me just check. P is equal to, we can just write poly, then 2, then 3, then is your x, right, comma, then is your r, right? If I give just like this, so P is equal to this, and oh, the spelling was wrong. Okay, factors of, then if I say P, then it will give x minus 3 into x minus 2. I suppose that answer also it will work because the spelling was wrong. Okay, the answer it is not taking. Okay, no problem. If I run this again, then it should take it. Yes. So actually answer is your temporary variable. So that time, next time it has just omitted the answer. So if I say the factors is your, that is your whatever factor of the polynomial is, that it will show, right? This is the factors. Now up to this, any doubt? Up to this, any doubt? So what we have done the how to define a polynomial, that is with the help of poly. Then we have done the roots, how to find out the roots, how to find out the coefficients, and how to find out the polynomial with coefficient and roots. And finally, we have done that how to derive it, how to find the derivative of a function, how to find out the Horner of a function. Horner matlab the value of the polynomial at a particular value, and then we have found out that how to calculate the factors, right? So these are the things till now I have done. Okay, next is your Pol fact. So Pol fact is also the to find out the factors of the polynomial. Now question is, what is the difference in that with the Pol fact and the factorial? Now I will tell you that what is the difference. Okay, so sometimes, for example, the polynomial equation is your, say whatever we have found out, x squared minus 5x plus 6, right? Say for example, the polynomial is 2x squared minus 10x plus 12. This is nothing but a multiplication by 2, right? If we give the factors, I will show you. If we give the factors of P, then we will find the result will be x minus 2 into x minus 3 only. It will not give the multiplying factor. But if you give the pole fact of P, then you will get 2 also, x minus 2 also, x minus 3 also. So this is only the difference between the factors and the pole fact. So what is basically the difference? Difference is that in pole fact, we get the multiplying factor as well as the other factors, but in case of factors, it will not include the multiplying factor. No, let me just check it. I will just tell you. So I am telling that okay. Okay, so let me just take it as a P is equal to 2 into x square. Sorry, 2 into x square. Now x is a polynomial, so we can write just like this: 2 into x square minus 10 into x, right? Plus 12. That means we are multiplying this 12 minus 10x plus 2x squared. So this is my P, right? Okay, the x values are there. Okay, just 1 minute. Another value we can take. P is equal to poly 0 comma m, right? Let me consider m as a polynomial first, then I will write P is equal to 2 into m square, then 10m plus 12. Why it is not taken? Poly m square. M is a poly. That should take it. Okay, no problem. Let me just say here only, let me describe. Okay, let me just describe a polynomial like this. Poly, then let me take the constant as your 12, then minus 10, then as your 2, right? So comma, then is your m. Okay, let me write like this. So 40. Okay, it is taking as a root. Okay, let comma, then I can give as your coefficient. These are my coefficients. So this is my the value, that is your 2m square minus 10m plus 12, right? That is my P, right? Now if I say that factors of this P, right, you will get the two values. You see m minus 3 and m minus 2, only two values, but two multiplying factor you are not getting. But if you give pole fact of P, right, you will get the three values. That means multiplying factor 2 also you are getting, m minus 3 also you are getting, m minus 2 also you are getting. So that is what the difference between the factors and the pole fact. For some cases we use the pole fact where the multiplying factor is not necessary. In some cases we can take pole fact, factors where those multiplying factor is not necessary. Next is your TRF. TRF mod matlab this is your transfer mode, right? So TRF mod, it gives the pole zero structure, right, of stabilized input and stable output. This is actually you can give the option, that is your H is your transfer function, and then is your, you can give that if you want to see the visualization of the poles or visualization in terms of frequency. Now we will just see that how it offers. Okay, so let me go to here. Now we have, let me see what is we have in P. We have P is this, and another one, for example, P1, something is your P1. Okay, so let us see that P3 equal to, say I am giving P by P1, right? So, okay, it is not taking, okay, no problem. So we can take P1 some other values, that is say another polynomial. Let me check. So it is not differentiate. Okay, let me, if I take P3 equal to P1 by P, it is also not taking. Okay, P1, let me just take the other variable 4, 5, and 6, comma, then okay, this is X and this is M, that's why it is giving. Okay, so I am giving M, right, comma, then we are giving that is your C. Right, another variable, another polynomial. It is giving error because in your P1 it is in X and P it is in M, right? So what I have done, again I have given another polynomial in terms of M. So this is we have got. Now we are giving that P3 equal to say P by P1, right? So something divided by something, that means actually we are getting in terms of transfer function. You know that what is transfer function, you must be knowing if you are electronics background or something. So transfer function is basically in terms of h, if you are telling something divided by something, that is your y by x. So this is actually the transfer function. So this h is basically the transfer function, and in the transfer function itself we can find out that what are the poles and what are the zeros. That means if something expression we are getting here, from there we can find out the zeros, and from the denominator we can find out the poles, right? So if we just write this equation, for example, we are writing this equation here, that is say S equal to, we are writing that TRF mod of H. H is our here P3. This is my transfer function, and within bracket we can just write that what you want to see. You want to see the poles, or you want to see the natural frequency or the damping frequency. So if you are writing that you want to see the poles, then automatically you can just see that it is giving gain is this, that means multiplying factor is this, numerator is m-3 and m-2, that means from here you will get the zeros, and denominator it is not able to differentiate, so it is giving as it is. So in the denominator it is unable to give you the poles values, right? So in that case what you can just say, see that these polynomial, this 6m square plus 5m or the whatever value you have got, he has written the common this 6, and then afterwards he has written this m square minus this m and that m. So you can just write it, and after that you can just solve it with the help of the that roots of this, and find out the in terms of the that imaginary values. So that way you can find out the poles also, right? For example, if I write that okay, that if I write that find out the roots of say okay, we have m square, 6m square, this is your P1, right? I am giving that roots of P1. If you want to give P1, then you can find out the roots are like this. That means in the denominator part, you will get this is actually the imaginary values. So this way you can find out the what are the poles and what are the zeros. So this is your TRF mod. TRF mod is giving the poles and the zeros of a transfer function. Next is your that COFFG. COFFG is your inverse of a polynomial matrix. Any doubt up to this? Any doubt up to this? Any doubt? Any one of you? That means we have found out the Horner factors, Paul fact, and finally we have done the TRF mod. कोई doubt है तो पूछो. I will repeat again. Yes, any doubt? Otherwise, you can write in the chat box. Okay, let me go further then. Okay, now we will see that what is the inverse of a polynomial matrix and the degree of a polynomial matrix and how to calculate, right? So we will see that first of all we just want to know what is the polynomial matrix. Let us see that what is the polynomial matrix. So if we write like this, polynomial matrix in the sense we have written in the morning half that is this is your actually matrix, right? This is actually one matrix. Now, if we want to write the polynomial matrix, so we want that we can write like this, that for example S, right? Then is your S square no sorry S square plus 1, right? This is also another matrix. For example, I just want to write that 2 into S, okay, 2 into S maybe, and another one say 2, right? What it is given? It is given that undefined operation for the given operands, right? That means it is not finding that S is a that is a polynomial term or polynomial variable. So it is not able to give me the answer. So if I want to write okay, S it should not be within code. Okay, let me just remove that code. Then 2S maybe I am writing. Then also it will give the error, right? It is giving that inconsistent row or column 1, 2, 3, and 4. It is +1. It is not taking. Okay. Say I am telling here. There is some value must be there in S. Acha, okay, S, there is some value. That's why it is calculating that. Okay, let me just take the another variable which is not there. Say T, right? Right, so it is giving that undefined variable T, right? So if we have the another this thing, for example, if we want that t square plus 1 and 2t plus 1, just like this, we can find out we can write the equation. Then what we have to do, we have to first declare t as a polynomial variable. Now, to declare the t as a polynomial variable, first line what we have to write, this. That means we are declaring t as a variable, right? T as a variable in the sense this as a polynomial variable, right? This way we have to just write, okay, we will write not a, that is t equal to polynomial t, right? We will just write this. So that means t equal to t in the sense that now you have declared t as a polynomial variable. Now we can write this equation, that is t is equal to t square plus 1. Then afterwards we can just write 2 into t, right? And last value may be equal to 2. So then you will get a matrix, and this matrix is known as your polynomial matrix. Am I clear? Am I clear? So first of all, directly when you want to write that coefficient matrix just like this, it is very much easy. You can just write the coefficient, then it will be a matrix. But if you want to write polynomial matrix, then whatever variable you want to use, then you have to declare that variable. For example, in terms of x you want to write, so you can just write x equal to poly of 0 comma then x. You have to declare that x is a polynomial. Then you can write, if you want to write, say this is your x directly. Otherwise it will give that indefinite variable or something. Then you can write 2 into x, for example. And second value, for example, you can just write 3, right? So this will be a polynomial matrix. Otherwise you cannot write with the variable x or y or z or p, right? You cannot write this. So this is actually polynomial matrix. Now if there is such a polynomial matrix, then with the help of this COFFG, you can find out the inverse of that matrix. And degree, if you want to find out the polynomial matrix, then you can write degree of that polynomial. Now I will just write that COFFG. Yes. Now I will just write COFFG of A, right? So it will give me the inverse of this polynomial matrix A. And if you write degree of A, then it will give the the degree of that polynomial. First one degree is your 1, this one degree is your 2, this one degree is your 1 because x to the power 1, and this one degree is your 0. So it is giving the degree of each and every polynomial, and this is giving the inverse of this matrix. Right? So this we have found out that how to carry out the inverse of a polynomial matrix. Then similarly, denomination of a rational number. So if you write denom, so it will give the denominator. If you find out the numerator, then you just write NUMER. So it will give the numerator of a numerator in terms of polynomial matrix. Determination, then another find out is your determ, DETERM. that is your determinant of a polynomial matrix. To find out the determinant of a polynomial matrix, we just write DETERM. So let us see that if we can just write that determ of say our matrix is your A. So if we just write determ of A, so it will give the determinant of a polynomial matrix, right? Okay, simplified. For the simplification, we can just write SIMP, that is simplification of this. Okay, P diff polynomial divisions, that is also P1 by P2 also you can write, or you can just write P diff, right? You can just write P1 by P2, or you can just write P diff P1 P2. If you write P1 by P2, then only you will get the quotient, and if you write P diff P1 and P2, then you will get the remainder as well as the quotient. That is only the advantage, right? So LCM, for the LCM, you can find out the different polynomial values you are giving and find out the LCM of that all those polynomials. That also you can give the LCM of this. I have given the equation example, and this presentation is also there with you, right? So this is all about the polynomial. Any doubt of this? Here we have again, just let me see just one or two lines. We have taken the polynomial. We have learned about the how to find out these equations, roots and coefficients. We have found out that how to find out the derivative, Horner, then factors. What is the difference between the factors and Polfact? Then TRF mod, that is your to find out the poles and zeros of a transfer function. Then to find out the inverse of a polynomial matrix. What do you mean by polynomial matrix? That we have found out. Degree of a polynomial matrix. Then also we have found out the numerator, denominator, determinant of a polynomial matrix. Simplified polynomial divisions. Then LCM also we have found out, and some other non-important some commanders also there. You can just try it yourself. Any doubt of this? This also I have I have just uploaded this value also. Yes, any doubt? Any doubt? Quickly. Quickly, I want the response from your side. Any doubt? Anybody? I can just repeat also if you find any doubt. Quick responses, please. Okay, so you can do the practice on your own, right? After 4 o'clock, you will get enough time to practice this, right? So today's whatever we have done, you can do the practice from 4 to 5 or 4 to 6, whatever your timings is there. And tomorrow morning again, I will take the class. So now the small sessions, just 10-minute sessions on the ordinary differential equation. This is known as your ODE, ordinary differential equation. That means how to find out the solution of ODE. So to find out the solution of any ordinary differential equation, we need the that boundary problems, then the maximum is your the equation and the boundary problems. So if our solution is your equation is your dy dx by is equal to fxy, then from here how to find out y? That is actually our motive, to find out the solution. That means to find out the value of y. So let us consider the equation is like this: dy by dx minus sine twice x equal to 0. and this is my boundary values or the boundary equation values. That is your when x equal to 0, y is equal to 0, and y not equal to also 0, right? Y is equal to y naught, that is equal to 0. That means when x equal to 0, y is equal to 0. So to find out this differential equation, what we do, first of all, we do all the equations. Whenever we get the equations, we write in this form that the dy by dx is equal to whatever in the right hand side we are getting. So from the equation itself, we are getting dy by dx equal to sine twice x. So this we have written, that is we have to rearrange the differential equation, because we have to get such type of equation, that is dy by dx equal to fxy. So dy by dx equal to sine twice x. This is my equation. So now we will write the solution. So as we know that we have written the how to write the function, I have already told. So function y dot, so this is my variable, right? Any variable. F is a function in terms of x and y, right? And y dot equal to what? This is equal to sine twice x. This is my sine twice x. Why we have written the sine twice x? Because here the function is your sine twice x. That's why we are writing that y dot equal to sine twice x and n function. This is my function, right? I have written one function. So this is my function. Now we are writing the actual programming. What is the programming? I am telling that y not equal to 0, x not equal to 0, because I have this boundary conditions with me. That is your x not equal to 0 and y not equal to 0. Then I am putting that x equal to 1 to 100 and difference is your 0.1. Just 0.1 for what we have written that 0.1 also you can take, 0.01 also we can take, so that you will get the smooth graph, right? Otherwise you will get the this like graph, right? So if you want to get the sinusoidal graph and smooth graph, then you have to take the difference is very less. You can take the 0.01 or 0.001 also, that also you can take. Now to find out the ordinary differential equation, we use the command that is your ODE. Now this is it should be my output, ODE of y naught, whatever is y naught, whatever is your x naught. This is your x, because x is your range, comma, and this is your f, whatever you have written sine twice x, this is my f. And after that, whatever it is coming in y, then you can just do plot y. Then all the values you will be receiving for 1 to 100, all values you can plot this, and it will be in the terms of this, the graph will be like this. So let us see that how we will get the value. Let me just put it into the Scilab notes. Right, this is my equations, and let me just do the file with echo. Then you see such okay, you can see that CLF. Right, you are getting like this. Now if you just say that if you are taking 0.01, then of course you may get the very small smooth graph, right? If you do not take this, for example, if you are not 1 to 100 only you are taking, you just see that how the result you will get some cross result, the smooth results you will not get, right? So this is actually basically you can just if you do not plot, then you will get the values only. For example, if you are giving this 1 to 10, and if you are file with echo, if you are writing, then okay, only 4 values or some values you must be getting. Let me just see that what are the values you are getting. So this is the value you are getting from this is the value. So for 1 to 10 values you are getting. For 10, since we have given that for x equal to 1 to 10, so what will be the y value? Y value also 10 values you will be getting. Now if you are giving that plot y, then you can just see that only 10 values it will plot. You just see only 10 values it will plot, right? So for x equal to 1, what is the value of y? X equal to 2, what is the value of y? X equal to 3, what is the value of y? Like this. X equal to 10, what is the value of y? And then it will put. So this way you just get the some values. But if you take the more number of values, then you can get the smooth curve on that. So that is only the advantage. I suppose that this is, it is understandable to you that what do you mean by ODE. And all the functions that I have given to you, this PPT is also there with you in ODE. There you can just do the practice that this solution, how to get this solution, that dy by dx minus sine x plus y minus exponential x minus exponential y is equal to 0 for x equal to 0 and y is equal to 1. That is the initial value, right? So this way you can just do the practice sessions of this, right? OD is not so much now important for this, and we can get the OD discrete, that is your discrete time simulation. That means for particular value you want the output, that is your same thing, or y naught is equal to 0, x equal to 0, x equal to 1 to 10. OD we have given that discrete, right? So y naught, x naught, and we are giving the particular value, not the all x values. We are giving 2, 3, 4 and 5. What is the value of f? So like this we are getting the 4 values of f, and then we can plot it or we can graph it. So whenever you will be wanting the discrete values, then we can give that 2, 3, 4 and 5. That means particular x values or y values you want to put it. So that is basically the ODE discrete. So that is, this PPT is also there with you. So this is all about for today's class. Now is the time for practice.